Hello everyone, in this video I'm going to be starting a new series, I guess, and it's going to be about the 12-fold way. First, what the 12-fold way is, so what we're going to be solving in this diagram. We have choice A, B, C, and choice A says there are no restrictions, and choice B says at least one per box, and choice C says no more than one per box. And here it's going to be the balls, and here would be the boxes. So for example, for this, since we have 1, 2, 3, and we have 4 of these 3s, that's why there's 12. And in this box, what we're trying to solve for is, with no restrictions, in how many ways can we put n balls into k boxes? And in this video, we will have 4 balls and 2 boxes. 1, 2, 3, and 4 balls going into 2 boxes. And every column that's on this side, so all of these 6 columns, the balls, all of the 4 balls are distinguished, so all of the balls are different. And if we are solving for the columns over here, all of these 6 columns, the balls are indistinguished, so the balls are, you cannot tell the difference, they are identical. And these 6 columns, the boxes are distinguished, you can tell the difference, and these 6 boxes are indistinguished, you cannot tell a difference. And that was just a phone ringing. And we're first going to solve this column right now. So we have 1, 2, 3, 4 balls. As you can see, you can't tell the difference. I numbered them. And we have 2 distinguished boxes, A and B. And these 4 balls are trying to get into these 2 boxes. The first ball had 2 choices to go into. It can go into box A or B, so that's 2 times. The second ball can also go into A or B. And the third ball can go into A or B. And also the last ball, number 4, the 4th ball, can also it can go to box A or B. So that will be 2 times 2 times 2 times 2, or 2 to the power 4, which is equal to 16. So the answer for A is 2 to the power 4, which is equal to 16. And for B here, for choice B, we have to at least have 1 ball per box. So that means that here we also included the ones, for example, we also included the ones where there wasn't at least 1 ball per box. So there could have been 0 balls in A and 4 balls all in B, or 4 balls in A and 0 balls in B. But in this one, we don't count the ones where there's 0 balls in a box. And the only way that can happen are these two choices, I guess. So we're going to subtract 2 from 2 to the power 4. 2 to the power 4 minus 2 is equal to 14. These 2 were the only 2 ways where there wouldn't be at least one ball per box. Now for choice C. Choice C says no more than 1 per box. So no more than 1 ball per box. And in this one, the answer is 0, because since we have 4 distinguished balls and 2 distinguished boxes, it doesn't matter that they're distinguished, it's just that there's more balls. So if the first ball goes into goes into box A, and the second ball goes into box B, then the third and the fourth ball have nowhere to go into. So there are 0 ways that would fit this column. And now for this column, we have 1, 2, 3, 4 distinguished balls with 2 indistinguished boxes. So these 2 boxes are supposed to look the same, and it's choice A, which means there are no restrictions. And so a way that we can do this is by counting all of the ways. So we could do it like first ball could go into here, while 2, 3, 4 balls go into here. And another way would be 2, 1, 3, 4. 3, 1, 2, 4, 4, 1, 2, 3. Or it could go like 1, 2, 3, 4. Or 3 can go over here, or there could be just 0 balls in this box and 1, 2, 3, 4, all of it in this box. But of course, there being 1, 2, 3, 4 balls in this box and 0 balls being here, these 2 would be the same, because you cannot tell the difference between these 2 boxes. We would only need to write 1. So this would be one way to solve for this problem, except that there's way too many and it wouldn't be fun to write all of it down. So we're going to do this another way. We can think of it as 0 balls going into this box and 4 balls being in the other box. There's also 1 ball being in this box and 3 balls being in this box, and 2 balls and 2 balls. These 3 would be the only ways there will be balls in these 2 boxes. And how many ways can the first outcome happen? Well, there's only 1 way, right? And for the second outcome, how many ways for these arrangements to happen? Since we have 4 balls and we can just think about the one here, that would be 4 choose 1, which is just equal to 4. So there are 4 ways for this arrangement to happen. For the third arrangement, we can just do 4 choose 2, which is equal to 6. So for this one, I will write it out to prove it. We can have 1 ball here, 2, 3, 4. The rest of the balls on this side of the box, and the second ball can be here with the rest. The third ball with 1, 2, 4 ball, and the fourth ball being in this box, and 1, 2, 3. These three balls being on the other box. So yeah, there's only 4 ways. And of course, it doesn't matter if these balls were on this side on this box, because these boxes are identical. And now if we add 1, 4, 6, we get 11. 1 plus 4 plus 6, that's 11. And now for B, the rule is we have to have at least 1 ball per box, and the answer would be the same, except we don't think about this one, because we have to have at least 1 ball per box. And the first outcome or the arrangement does not follow the rule. And so basically we just have to subtract 1 from 11 and we get 10. I see that I made a mistake. The answer is not 10 for B and it's not 11 for A. Because here I made a mistake, and here we have the same number of balls in each box. And so we would have to divide it by 2 factorial, which would have been equal to 3. And so if we had three identical boxes with 5, or just with 4 balls and 1 ball here, 1 ball here, and 2 ball here, we would also do divide by 2 factorial of the. But if we, well, yeah, that's basically it. So I made a mistake here. That was supposed to be 3, so that means that's the answer. For A would have been 1 plus 4 plus 3, which is equal to 8. And B would have been 8 minus 1, which is equal to 7. And the reason I put a star here is because number B is it's the Stirling problem of the second kind, and my brother David will be making that video. We'll be making a video of that problem. And the Stirling problem, it doesn't always have to have 4 balls and 2 boxes like here. It can have 4 balls, 3 boxes, 5 balls, 2 boxes, and 5 balls, 3 boxes, like that. It doesn't matter. It's just the Stirling problem is just the balls being distinguished and the boxes being indistinguished. And the rule is that there has to be at least 1 ball per box. So watch that video. It'll be like 3 videos, I think. And for C, it's the same. Like I said, it doesn't matter that the balls are distinguished or not distinguished. It doesn't matter that the boxes are distinguished or not distinguished. It's just because there are more balls than boxes, there's 0 weight. And the same for the rest. Okay, now I will solve for this problem. We have 4 indistinguished balls and 2 distinguished boxes. Boxes A and B. And we're going to do it the same way we solved for problem A and B here. We're first going to write out the number of outcomes. So there could be 0 balls here and 4 balls here. Remember that there are no restrictions for A, choice A, so we can have 0 balls in a box. And we can also have 1, 3, 2, 2. Okay, now, how many ways can this happen? There's only 1. Well, there can be only 1, except that now the boxes are distinguished. So there could be 4 balls in a box A, in box B, and 0 balls in a box A, or there could be 4 balls in A and 0 balls in B. So that's actually 2 outcomes. And it's the same for this. It would originally be 4 ways, except since these 2 can change, it would be 8. Oh yeah, no. It wouldn't originally be 4 because there would just be 1, since the balls are indistinguished. So this would also be 2. If I were to write it out, it would just be 1, 1, 2, 3, 1, 2, 3, 1. Yeah, so these 2 would just be the ways. And now these two, but just this outcome, it would also be 1, except that there's 2. But here again, there are 2 same number of balls in each box, so we have to divide by 2 again. And that would make up 2 plus 2 plus 1, which is 5. And so that would be the answer for choice A. For choice B, there has to be at least 1 ball per box, so we don't have to think about this one. And that would just be 2 plus 1, which is equal to 3. 2 plus 1, which is equal to 3. And now we have this column, which both the balls and the boxes are indistinguished. And there are no restrictions. And here we're also going to write out the arrangements. 0 balls in this box, 4 balls, 1 ball, 3 balls, 2, 2. And for this to happen, well, actually these are all just 1, 1, 1. And the reason is because they are both indistinguished. So if I were to write all of them out, well, the 1 for this, the 1 for this, and the 1 for this, it would just be 0 and 1, 2, 3, 4, 1, 1, 2, 3, 1, 2, 1, 2. And it doesn't matter that it can switch because the boxes are also indistinguished. So that will be 1 plus 1 plus 1, which is equal to 3. And for B, at least 1 ball per box. We just cross this out and we have 2. So that will be 1 plus 1, which is equal to 2. So we filled out all of the columns in this video. So for the next video, we will have 4 balls and 3 boxes. Thank you for watching, everyone, and have a great day.